Hey all, welcome back to another video. Today's first question is, if x, y, and z are integers such that 2 to the power of x times 3 to the power of y times 7 to the power of z equals 392, then what is x times y times z? So since 2, 3, and 7 are all prime factors, we can either prime factorize 392 and pick out all the 2, 3s, and 7s and then see how many there are, or since if this equation, and 2, 3, and 7 are already primes, if this equation actually works, then x, y, and z would have certain values that this equation would equal 392. But what if we're solving just for x, y, and z, what if one of these don't actually work, and then we can just make the job a lot easier? So, for example, we know that 392 is definitely divisible by 2 since it kind of does end in 2. But it is not divisible by 3. This number, 392, is not divisible by 3 because, as you can see, all the digits that are added together are not divisible by 3. So that means that this number has no 3's in it, which means that there are 0 3's. Therefore, y would equal 0. And we don't need to solve any further here because we know that, well, there's x. X definitely has a value, but we don't really need to solve for z anymore because this is asking for x times y times z. And any number multiplied by 0 is still 0. So this number is 0. Moving on to problem number 2. This number, I'm not feeling like saying it right now because it's a 6-digit, is divisible by each of 2, 3, 6, and 8. What is the next number, the next larger integer that is divisible by 2, 3, 6, and 8? So I've done problems similar to this in the past. You guys can go watch those videos, but it's basically, since this number is divisible by all 4 of these integers, then if we're trying to find the next larger one, we're just going to add their LCM, which is like the one that all of them, the smallest number that all of them are divisible by. And then we can add that to this number because that's just a certain number of their LCMs. So taking that idea, we're basically going to go 2, 0, 6, 4, 9, 6 plus LCM 2, 3, 6, and 8. But since 6 is already a multiple of 2 and 3, we don't really need to solve it because during the process of LCM, we're pulling out the largest primes from each one. And since 6 already has a 2 and 3, this is the LCM of 2, 3, 6, and 8 is already equal just to the LCM of 6 and 8. So taking that idea, we just need to do LCM 6 and 8. And then in LCM 6 and 8, if you LCM that, you're going to go dividing by 2, top and bottom. You get 3 and 4, so you multiply this all together. 12 times 2, which is 24. Put this in a corner space, somewhere where it doesn't bother me. Boop. Okay. So now we know that the LCM is 24. So when basically we have to, if we add this all together, we're going to be adding 24. And 6 plus 4, 10. 9 plus 1 is 10 plus another 2, 12. Carry over the 1. And then you would get 6, 0, 2. So the answer is 2, 0, 6, 5, 2, 0. Add a comma there if you want to be fancy. Moving on to problem number 3. A positive integer is 3 more than a multiple of 4 and 4 more than a multiple of 5. What is the least integer it could be? So this one is also another LCM problem. You guys can notice here, since y'all are very smart, that 3 is, if you go 4 minus 3, you would get 1, and 5 minus 4 is 1 as well. So basically, we're going to be looking for a number that is 1 less than the LCM of 4 and 5. So taking that idea, if we write this into an equation, we would get LCM 4, 5, minus 1. So if we solve for this here, the LCM of 4 and 5 is obviously just 20 because 4 can be written as 2 to the power of 2 and 5 is already a prime. So we then go 20 minus 1, in which we would get 19. And we can check if this is actually real, because we can find the multiple of 4. 19 minus 3 is 16, which is a multiple of 4. And 19 minus 4 is 15, which is a multiple of 5. So our answer is 19. So yeah, that's the end of this video. I hope you guys enjoyed it, and I hope you guys learned something new. And I'll see you guys on the next one. Bye!